In example 9, we're asked to find the level curves to the graph of 6 minus 3x minus 2y. So we can proceed with this problem the same way we applied the level curve process to our paraboloid in the previous example. But sometimes it's convenient to almost do them all in one pop. So suppose we set f of xy equal to k without evaluating that k at 6, 0, 6, or 12 yet. So f of xy is equal to 6 minus 3x minus 2y. And again, that's equal to k. And I'm going to move that 6 over to the right-hand side. So we have negative 3x minus 2y is equal to 6, or rather, k minus 6. And this is an equation of a line. And with these equations, it might be more convenient to work with positive coefficients than negative coefficients. So let me multiply both sides by -1. It's not essential, but it's just a little bit more convenient for me. Okay, so these are equations of lines, and consider that now I just need to plug in the various values of k here to get our equation of the line. So when k is equal to -6, our line is going to be 3x plus 2y is equal to, let's see, -6 plus 6, that gives me a 12. When k is equal to 0, I got 3x plus 2y is equal to -0 plus 6, that's just a 6. When k is equal to 6, I got 3x plus 2y is equal to 6 minus 6, which is a 0. And when k is equal to 12, I got 3x plus 2y is equal to 12 minus 6, which is just a 6. So I can graph all 4 of these lines on the xy plane, starting with 3x plus 2y is equal to 12. Here I'll use a little bit of a trick to give me some insight on what the x and y intercepts are. I can block out the x here, and I know that my y-intercept is the solution to 2y is equal to 12, so 6. I can block out the y here, and I can know that the x-intercept is whatever solves 3x is equal to 12. So in that case, it will be 4. And I can connect these two dots together to give me my level curve. So this guy right here is the level curve for k is equal to -6. I can continue the process for our second line here. The x-intercept is 2. The y-intercept is 3. Connect these dots to get your level curve. And again, that's the level curve for a k value of 0. For the third line, that is a little trickier because the x and y-intercept are 0 and 0. But if you took this guy, this equation, and solve for y, you would have that y is equal to -3 halves x. And I can totally graph that. So I can take this point, go down 3 units, over 2 units to get my second point on my graph, then connect the dots. That guy is the level for k is equal to 6. And finally, for our last line here, we have that our x-intercept is 2 and our y-intercept is 3. Hold on a second. Give me 1 second. I think I might have made a mistake somewhere. Aha, I did, because I should have put a 12 in here. I put it in the wrong formula, folks. So that's negative 12 plus 6, so that's negative 6. Sorry about that. So the x-intercept is negative 2. And the y-intercept is negative 3. Connect the dots, and you got yourself your level curve for a k value of 12. So again, level curves are attempting to take something that is three-dimensional and project its information into something that is two-dimensional. So when your x's and y's, let's say, are right here, if I'm going this direction, am I going up or down? Notice that this level curve is 6, so that tells us that the altitude of our three-dimensional graph is 6 units high. This k value is 0. That means that the altitude is 0 units high. So going in this direction tells you that you're going down. So again, if I'm starting from this point right here and headed in that direction, I'm going downwards. Alternatively, if I'm starting at this point over here and going in this direction, in my three-dimensional graph, I will be going upwards. You are actually quite familiar with this idea because that's exactly what a map does. Your old standard map, your two-dimensional map that you use to travel from one part of the city to the other, right? The Earth is three-dimensional, but whenever you use a map, it's two-dimensional. Consider that the level curves are sort of giving you the information of the elevation that you're experiencing as you travel from one point of the city to another point of the city.